right, so this next section here, I think you're either going to like, it's going to come really quickly to you, or it's not, because it's about recognizing a pattern, which all of us are at different levels of how much we like looking for patterns and finding patterns. So I want to be able to describe the pattern, I want to be able to write the next term, and I want to write a rule for the nth term. So if they said, look at this list of numbers, find the 20th term, I don't want to have to go, well, first I have to add, I don't want to have to add 2 20 times. I want to be able to write a rule. So letter A. What I would look at here is the first term is -1, the second term is -8, the third term is -27, the fourth term is -64. And what you may or may not have noticed is it at least is shaping up to be the term number, which is n. So these red numbers up here are n, and I raised it to the third power. Almost, because it's a -1 and a -8, so I took -n and raised it to the third power. So I would say something like a sub n equals -n to the third power would be my rule. So then they say find the next term. Well, when n is 5, -5 to the third is -125. So describing the pattern would probably be to say, well, it's each perfect cube, but the negative version of that. I'm not going to write it down in words, but the next term is -125, and the rule is a sub n equals -n to the third. So maybe pause the video here and see if you can write a pattern for B, and then the practice problems if you want to. But then you can follow through with me if maybe the patterns aren't coming as naturally to you. So when I look at B, I have to think about it in terms of the fact that the first term is 0, the second term is 2, the third term is 6, and the fourth term is 12. And the more practice you get, the easier this is going to be. So I would be in my math repertoire. We've got cubes, so we've got squares, we've got adding, we've got subtracting, we've got multiplying, we've got dividing. How did they take an n of 1 and somehow get 0? How did they get that? How did they get the first term to be 0? And how did they take an n of 2 and do the same action, but get 2 that time? And how did they take, that would be the second term, how did they take an n of 3 and get that the third term is 6? How did they take the n of 4 and get the fourth term is 12? And they have to do the same pattern every time. So did they add? Did they subtract? Did they multiply? Did they divide? What they do? So they somehow took an n of 1 and got 0. So that's 1 minus 1. But you have to think, what does that mean the pattern is? Does that mean that I take, that could be two things. That could be n minus n, or it could be n minus 1. In either of those cases, though, it doesn't work here because 2 minus 2 is not 2, and 2 minus 1 is not 2. So I didn't do that subtraction. I didn't add because you don't take 1 and add something to get 0. Did I multiply? Maybe I multiplied. So how do you multiply this n of 1 and somehow get 0? Well, 1 times 0. So that could be two different things. That could be n times 0. But obviously that's not the case because 2 times 0 is not 2, etc. So let's think about what else 0 is. Well, 0 is 1 less than 1. So how would I represent 1 less than n? I would write n minus 1. So 1 times 0 is the same thing as taking n and multiplying it by n minus 1. Taking the term number and multiplying by 1 less than the term number. So 1 times 0. What would that mean for 2? Well, that would mean that I would take n, which is 2, and multiply it by 1 less than that, which is 1. And 2 times 1 does equal 2. So then 3 times 1 less than that is 3 times 2, which is 6, and then 4 times 1 less than that is 3, so 4 times 3 is 12. So for 5, to continue the pattern, I would take the term number, multiply by 1 less than that, so the fifth term is 20. So the answer to what is the fifth term is 20, And what is the rule is that I took n and I multiplied it by n minus 1. So a sub n equals that. So I would say that this I actually like better than you distributing the n, unless you just so happen to recognize if the n squared minus n. So maybe you thought, oh, well, they took 1 squared and subtracted 1. They took 2 squared and subtracted 2. They took 3 squared and subtracted 3. You could have thought about it that way as well. So either would be fine. I would do some guessing and checking on big ideas as far as what format they want the answer in. But both are equally as correct. So like I said, finding these patterns is going to be easier or harder depending on the person. Okay, so maybe you can pause the video again and you can try your hand at these problems and then we'll go over them. So I always start by labeling them because that's the mindset that I'm in. If you can recognize patterns on your own, then you can definitely take your own approach. But I want to be able to do this consistently. So instead of looking at, okay, I'm adding 2 each time. Well, how do I put that in a rule? You could come up with that for sure. But I would look at if the first term is 3, the second term is 5, what am I doing in comparison to that number? So when I look at 3, how does that compare to 1? Well, 3 is 1 plus 2. So it could be n plus 2. 5 is not 2 plus 2 though, so it can't just be as simple as n plus 2. So what else is 3? Well, it's n plus 2, it was 1 plus 2, but what is 2? 2 is n plus 1. The first term plus 1 more than that. So then 5, does that work? 5 is 2 plus the next number, which is 3. So that worked. What is 7? 3 plus the next number is 4, so 7. And then 9, oops, how did I do that? 9 is 4 plus the next number is 5, so that works. So I take the term number and I add n plus 1. So I take n and I add n plus 1. So a sub n is 2n plus 1. And so that would make the next term no matter what 11, because I am adding 2 each time. But it's not that I started at 0, I started at 1. So 2n plus 1, the next term is 11. Okay, letter B. Here's what I did to recognize this. So 3, how did I get 3? How did I get 8? How did I get 15? How did I get 24? So the first term is 3. 3 is 1 times 2, or 1 plus 2, sorry. 8 is not 2 plus 3, so that doesn't work. And I could try some other ways. I could say what else 3 is, but here's what I recognize. 3 is 1 less than a perfect square. 8 is 1 less than a perfect square. 15 is 1 less than a perfect square. 24 is 1 less than a perfect square. But it's not that 3 is 1 less than n squared, because in the first term, n is 1. So 1 squared is 1, but 2 squared is 4. And then I subtracted 1. So I subtracted 1 each time. I just have to figure out a way for the first term to include 2 squared. And how that happens is that I take n plus 1 squared. So the first term is 2 squared minus 1. The second term is 3 squared plus 1, which is n plus 1. The third term is 4 squared. So it's the n plus 1 squared minus 1. And so et cetera, et cetera. So the rule is that a sub n equals n plus 1 squared minus 1. So then what's 1 less than the next perfect square? Well, the next perfect square is 36. So the next one would be 35, which you would also get if you plugged in a 5 into that equation. So yeah, they're tricky. I mean, there's no getting around that. The next one, so 1, -2, 4, -8. So what does it look like they did? Well, 1 squared is 1, 1 times 1 is 1. So I'm going to have a negative involved in the mix there. So I know when it comes to my term, I'm going to have a negative. Let's see what they did. 2 squared is 4. 3 squared is 9, so that's not how it works. But what are 1, 2, 4, and 8? They're powers of 2. 2 to the 0 power is 1. 2 to the first power is 2, and we can figure out what to do in order to make a negative and then make the positive or the 4 positive. So it looks like for the first term, they raised 2 to the 0 power. So what is 0? Well, it's 1 minus 1. In the second term, they raised 2 to the first power, which is 2 minus 1. So it looks like they took the number 2, a -2, and they raised it to the power of n minus 1. And in order to account for the fact that every other term is positive, I'm going to put that -2 in parentheses. So the rule is that a sub n equals -2 to the n minus 1. And so the next term would be -2 to the fourth power, which is a positive 16. And then letter D, 2, 5, 10, 17. So I have to think, what did I do to get, how did 1 become 2? How did 2 become 5? How did 3 become 10? How did 4 become 17? And I'm going to look at the perfect squares again. So the fact that I'm adding 3 and then I'm adding 5 and then I'm adding 7, the fact that it's consistently going up is actually kind of a hint at perfect squares, because that's how perfect squares are separated. That's why when we were graphing quadratics, we went over 1 up 1, over 1 up 3, over 1 up 5. Perfect squares are separated by consecutive odd numbers. So all that means is I don't want to lose the fact that I could be squaring something along the way. So 1 squared is 1. Plus 1 gives me 2. 2 squared is 4. Plus 1 gives me 5. 3 squared is 9. Plus 1 gives me 10. So it looks like I took the term number squared and I added 1. So a sub n is equal to n squared plus 1. So that would make 5 squared plus 1, 26. So like I said, we all are going to recognize patterns, some easier, some more challenging, but just practicing is the best advice so that you have extra tools to be on the lookout for.